Now here's the second part of the lesson, the remainder theorem. The remainder theorem says when a polynomial p of x is divided by x minus b, the remainder is p of b. So that means that if I substitute the value of b, now notice it's b, not negative b, it's x minus the number, b in place of x, I actually get what the remainder would be if I divided x minus b into that original polynomial. And so in this example, we're asked to find the remainder if this polynomial is divided by x minus 1. And so we would substitute 1 in place of x to find what that remainder would be according to the remainder theorem. So we substitute 1 in place of x, 1 here, and 1 here. And we evaluate all that. 1 cubed is 1 times 3 is 3. 1 squared is 1. 8 times 1 is 8, minus 7. And so 3 minus 1 is 2, plus 8 is 10, minus 7 would be 3. So the remainder should be 3. We'll verify that just by doing the division, because actually, especially the synthetic division is very short, very quick, just as quick as doing this calculation here. So we're dividing into 3x cubed minus x squared plus 8x minus 7. So 3, negative 1, 8, negative 7 goes here. We're dividing by x minus 1, so 1 would be the restriction. So we put 1 here, because 1 minus 1 makes that have a value of 0. Bring the 3 down. 3 times 1 is 3. Negative 1 and 3 add to 2. 2 times 1 is 2. 8 and 2 add to 10. 10 times 1 is 10, so we put a 10 here. And negative 7 and 10 add to 3, so same remainder is here. So the remainder is 3. Another example, we're asked to find the value of k, and notice that k is the linear coefficient, the coefficient of the linear term, and or the x term. We're told that if we take this polynomial and divide it by x plus 2, we get a remainder of 27. So we're asked to find what number k has to be in order for that to be true. Now we're talking about dividing this polynomial by x plus 2, so let's find out what the remainder would be in that division. So we would put negative 2, x minus negative 2 is the same as x plus 2, negative 2 in place of x here, here, and of course here. And that should equal 27 because we're told that the remainder is supposed to be 27. Now we'll drop the p of negative 2 because this is our equation here to find k. Now negative 2 cubed is negative 8 times 2 is negative 16. Negative 2 squared is 4 times 8 is 32. Negative k times negative 2 is 2k plus 1 is 27. Now negative 16 and 32 add to 16 plus 1 would be 17. So this is really just 2k plus 17 equals 27. And we subtract 17 from both sides then. We get just 2k on the left. 27 minus the 17 would be 10. Dividing out the 2, we get k to be 5. So k would have to be 5 in order for, when we divide this by x plus 2, to get a remainder of 27. Now you could solve this with synthetic division or long division, but it would be very long and complicated. The remainder theorem is definitely the way to go here. This calculation is much shorter than if you use synthetic division. One more example. We're asked what's the remainder when this polynomial is divided by 3x minus 2. Now in order to find that number that you substitute in, it's really the same as the restriction in the division. And so we would take the 3x minus 2 and say it cannot, that's the restriction, cannot equal 0. So 3x cannot equal 2. So dividing out the 3, we get 2/3. So that's the number that you would substitute in place of x everywhere in order to find what the remainder would be. So we put 2/3 in place of x everywhere. Now over here at the beginning, multiplied by a 12, we're cubing the 2/3. So 2 cubed is 8, 3 cubed is 27 in the denominator, 2 squared is 4, and 3 squared is 9 in the denominator. And there's no other powers over here. Now, when I multiply 12 by 8/27, there's some dividing out that can make this simpler. And so notice that if I divide 3 into 12, it goes 4 times, and 3 into the 27 in the denominator goes 9 times. So we're actually just left with 8 times 4 over 9, which is 32 over 9. So that's 32 over 9. Now just multiplying this out, negative 11 times 4 is negative 44. 1 times 9, the denominator is 9. And actually my common denominator is going to be 9. So, though both of these have been from the beginning, the 17 times 2/3, I'm going to get a common denominator of 9. And so what I would do is multiply that by 3, top and bottom. So that's where the 9 comes from here. 3 times 17 is 51, times 2 is where the 102 comes from. So we have 102 over 9. And the negative 6 in the end has the denominator of 1, so I multiply it by 9 over 9. So that's where the negative minus 54 over 9 comes from. And so we would just go 32, take away 44, plus 102, minus the 54. And of course that's all over 9. That gives you 36 over 9, which divides out to 4. Now we'll verify this by using synthetic division, that the remainder is 4. Just another way to do this. And so the synthetic division would look like this: 12, negative 11, 17, negative 6. The restriction, remember, was 2/3. That's why we have 2/3 here. Bring the 12 down. And so now we're going to multiply 12 by 2/3. So 2/3 times 12. The 3 goes into the 12 4 times. So 2 times the 4 that's left is 8. And so we add negative 11 to 8, which of course is negative 3. Now we multiply that 2/3 by the negative 3. And 3 goes into negative 3 negative 1 times. So 2 times negative 1 is negative 2. And adding that to the 17, we get 15. So one last time, 2/3 times the 15. The 3 goes into 15 5 times, and 2 times 5 is 10. So negative 6 added to 10 gives us a remainder of 4. And so the remainder is 4. And that's the end of the lesson.